Hello students. Welcome to today's class. We are going to talk about rectilinear acceleration. Before we proceed with today's lesson, remember, in our previous class we learnt about the concept of speed and velocity, the difference between speed and velocity. We also learned how to plot and interpret speed on a distance-time graph. By the end of this lesson, you should be able to know the concept of rectilinear acceleration, know how to plot and interpret acceleration on a velocity-time graph. Now, without further delay, let us dive into today's topic. The term rectilinear acceleration means the rate of change of velocity along a straight line path with respect to time. When the velocity of an object changes, it could be said to accelerate or decelerate. Acceleration is defined as the increasing rate of change in velocity with time. It is commonly referred to as positive acceleration. Deceleration, on the other hand, is defined as the decreasing rate of change of velocity with time. It is also called retardation or negative acceleration. An example of rectilinear acceleration is free fall. An object falling under the force of gravity, like a fruit falling from a tree. Rectilinear acceleration can be observed in various applications such as transportation, animal movements, the movement of objects and equipment. The SI unit for rectilinear acceleration is meter per second square, while its formula is change in velocity divided by change in time taken, which is denoted as A equals V2 minus V1 divided by T2 minus T1, where A is acceleration, V2 is final velocity, V1 is initial velocity, T2 is final time, T1 is initial time. There are several types of rectilinear acceleration, such as uniform acceleration and non-uniform acceleration. Uniform acceleration occurs when an object's velocity changes at a constant rate over time. In other words, the acceleration remains the same throughout the motion. An example of uniform acceleration is when a skydiver jumps out of a plane, the skydiver falls or accelerates at a constant rate due to the gravitational force of the Earth. Non-uniform acceleration. Non-uniform acceleration occurs when an object's velocity changes at a varying rate over time. In other words, the acceleration is not constant throughout the motion. An example of non-uniform acceleration is a car going in a curve. The acceleration of the car changes as it turns. Next, we are going to talk about the graphical representation of rectilinear acceleration. The velocity-time graph is used when plotting a graph for acceleration. A velocity-time graph, also known as speed-time graph, is a graphical representation of an object's velocity, or speed over time. In a velocity-time graph, time is plotted on the horizontal axis, which is the x-axis, while the velocity is plotted on the vertical axis, which is the y-axis. The shape of the graph can reveal various characteristics of an object's motion, such as its direction, acceleration, and deceleration. Here are some important features of a velocity-time graph. Slope. The slope of the graph represents the object acceleration. The horizontal slope represents an object moving with constant velocity, while a steeper slope indicates an object with greater acceleration. Positive slope. A positive slope on a graph indicates that the object is moving in a positive direction, or towards the positive end of the axis. Negative slope. A negative slope on the graph indicates that the object is moving in a negative direction or toward the negative end of the axis. Curvature. The curvature of the graph can reveal information about the object acceleration. If the graph is curved, it means that the object is experiencing change in its acceleration. Now, let's solve a practical question, so we can get a better understanding. A car runs at a constant speed of 20 meters per second for 3 seconds, and then accelerates uniformly to a speed of 30 meters per second over a period of 5 seconds. Plot and interpret the question on a graph. Find the acceleration. To solve this question, first of all, we will have to draw our velocity time graph, then choose a scale for each axis. For the x-axis, our scale will be 2 centimeters to 1 second, which is 1, 2, 3, 4, and 5. While the y-axis will be 2 centimeters to 5 meters per second, which is 5, 10, 15, 20. Next, we are going to mark the point where our change in velocity meets with our change in time, or you can as well say, the time over which the acceleration occurs. Our change in velocity is final velocity minus initial velocity, which is 30 meters per second, minus 20 meters per second, which will give us 10 meters per second. So our change in velocity is 10 meters per second. Next, we need to find the time over which the acceleration occurs, which is 5 seconds. So we will mark the point where 10 meters per second meets with 5 seconds. Then draw a slope from 0. Make sure it meets with the point we marked. We are done with our velocity time graph. If you move step by step, you will find it easy to plot. Remember, learning is a journey, not a destination. Next, we are going to calculate our acceleration from the velocity time graph above. To calculate the acceleration, remember, our formula is A equals V2 minus V1 divided by T2 minus T1, which is change in velocity divided by change in time. Our change in velocity is 10 meters per second. Our change in time is 5 seconds, which will give us 10 meters per second divided by 5 seconds, which is 2 open bracket meter per second divided by seconds close bracket. Always remember that when you divide a unit by itself, the result is squared, so our answer is 2 meters per second square. Note: there are 3 things to remember when calculating for acceleration, which are: when an object moves or accelerates from rest, its initial velocity is 0. When a body comes to rest or stops, its final velocity is 0. When a body's velocity is constant or not changing, its acceleration is 0. Good job, students. You are doing great. I have 2 assignments for you to work on. Number 1. List 2 differences between uniform and non-uniform acceleration. Number 2. A train moves at a constant speed of 50 meters per second for 120 seconds, and then accelerates uniformly to a speed of 60 meters per second for over a period of 200 seconds. Plot and interpret the question on a velocity time graph. Calculate its acceleration. Break it down and solve. It's less overwhelming than you think. Before we end today's class, let us summarize on what we learned. Today, we learned about the concept of rectilinear acceleration, how to determine acceleration. We also learned how to plot a velocity time graph. Alright, students. Great job today. In our next class, we are going to talk about scalar and vector quantities. Thanks and goodbye.